We're going to look at some more ways of setting up proportions with triangles. So the triangle proportionality theorem just says that if you have a triangle and then another line going through it that's parallel to the base, then that line going through the middle divides it proportionally. So we don't have to do a small triangle over big triangle. We can just take AE, this side, over EB, and that will equal AF over FC. You can just take the sides of the sides that are split by the parallel line. So you don't have to do the small triangle over the big triangle. It's just this piece over the larger or the other piece. It splits the sides proportionally. And the converse is also true. So if you were to say that backwards, if these sides are split proportionally, then those lines must be parallel. So it's true both ways. If the lines are parallel, it's proportional. If it's proportional, the lines are parallel. So here we have the lines are parallel because it's marked that way. We're supposed to find CY, which is right there. So we're going to set up our proportion. We can take 9 over 4 equals 10 over x. The sides are split proportionally. So 9 over 4 equals 10 over x. Cross multiply. 9x equals 40. So that's 4.4 repeated. Or you could have just left it as a fraction, 40 over 9, that would be okay. Same thing going on with this. You see the lines are parallel, so it is split proportionally. We're trying to find PN, which is just that piece. So we have the proportion 5 over 2 equals x over 3. If you set that up such that they were all flipped, if you did 3 over x and 2 over 5, that would have worked out too. So cross multiply, you get 2x equals 15. So x equals 7.5, 7.5. Extremely similar questions going on here. DG, that's that segment right there, so we can set it up. 32 over 24 equals 40 over x. Just take the top piece over the bottom, top piece over bottom. So cross multiply, 32x equals 40 times 24. And then divide by 32, you get x equals 30. So when you set this up, you get 8 over 5 equals 10 over Rn, the thing we're looking for. Cross multiply, that's 8x equals 50. So you divide by 8 and you get x equals 6.25. So we can use the converse of the triangle proportionality theorem to verify that lines are parallel. So if you want to know if MN and KL are parallel, you just check to see that the sides are proportional. So if 42 over 21 equals 30 over 15, if that's true, then the lines are parallel. So you can either reduce both of them to be 2 over 1, 2 over 1, so yes, or you could cross multiply and you get 45 times 15, which is 675, or 42 times 15 is 630. And then 21 times 30 is 630. Since we got the same number, yes, or you could have reduced. But then they are proportional, which means yes, they are parallel. Do the same thing here for DE and AB. If the side lengths are proportional, then they're parallel. So we're told AC, which is the entire length, is 36. So since we know that this piece on the right is 20, that means the piece on the left would have to be 16, so that they add to equal 36. And then BC is 27. So if the entire length there is 27, the side on the right is 15, so the side on the left must be 12. So then you have your proportion, 20 over 16 equals 15 over 12. You could reduce each of those to be 5 over 4 to show that they're equal, that they're proportional. Or you could cross multiply 16 times 15 is 240, and 12 times 20 is 240, and that also shows that they're proportional. So the sides A, B, and DE are parallel because the sides are proportional. When you set this up, you get 67.5 over 54 equals 90 over 72. So if you cross multiply to verify that these are equal, you get 72 times 67.5 is 4,860. And then 54 times 90 is also 4,860. So they are equal, which means they are proportional, which means the sides are parallel. So we're going to construct the mid segment, and then the mid segment is just goes from midpoint to midpoint. So you're going to pick two sides and find the midpoint of both of those sides and then connect them with a straight line. So let's do the bottom side here. Now remember, for the to find the midpoint, you stretch it more than halfway, which I don't know if I can do that with this. It's less than halfway. I shrunk down the shape so I can reach it. So now with the compass, you stretch it more than halfway. Draw a semicircle. And then without moving your compass, you move it to the other vertex and draw another semicircle. So now if you connect those two intersections, those two X's, you find the midpoint there. We don't really need any of those markings left over. We just need that midpoint. So now we already have one midpoint. We need to find another. So since we're already on this vertex, as long as we are stretched more than halfway, which we are, you can adjust your compass if you want to. I don't want to. I'm just going to keep it. Draw a semicircle here. And then move it to the other vertex for that side. And draw another semicircle. So if you connect those two intersections, you have the midpoint. So now the line that connects the midpoints, that's called the mid-segment. So we constructed the mid-segment. It's right here. Connects midpoint to midpoint. Now, we're going to do a little proof that the mid-segment creates two similar triangles. So, if you think about what we've got going on here, this mid-segment made these two sides be the same length. That's what a midpoint does. It splits into two congruent sides. Same thing with this midpoint over here. So since the midpoint splits it into two congruent sides, we know if we got rid of all those other lines, it would just look kind of like this. We said X, X, Y, and Y, just to kind of simplify our drawing for a second. So if that's our triangle, we would then know that these sides are parallel because we could take the proportion X over X equals Y over Y. Which X over X equals 1 and Y over Y equals 1, so yes, that's true. So that means that these sides are parallel, which means the two triangles are similar because of corresponding angles are congruent, which means the two triangles are similar because of angle. So we just went through the proof. Now we're going to write it down. So statement on the left, reason on the right. Now, if we're going to do a proof, we probably want some letters in here, so I'll call that A, B, C, D, and F. You can choose E if you want. It doesn't matter. We'll do E. So we know that B is the midpoint, or actually BC is the mid-segment, because that's what we constructed. That was given, we constructed it. So that means that AB is congruent to BD. That's what a midsegment does. That's the midpoint. And we could say the same thing with the bottom sides. AC and CE are congruent. So if they are congruent, then like we were just showing here, x over x equals y over y, that means that AB over BD is equal to AC over CE. Could just say something about they're congruent, which means that would reduce to 1 and that would reduce to 1. So let's just say congruent means proportional. So that then means that BC and DE are parallel. That was way back here at the beginning. The triangle proportionality theorem. So since they are parallel, that means angle ADE and ABC are congruent. Parallel leads to congruent angles, that's corresponding angles. We can say the same thing for angle AED. Just be the other angle over here. And ACB. So two angles are congruent, which means the triangles are similar because of angle length. So that's one way. There's many ways you could have shown this. You could have also gone the route of angle A is congruent to angle A because it's reflexive in both of those triangles. Then you would just have to show that x over 2x equals y over 2y for the entire length, and then you'd get side angle side similarity. It would be pretty similar, but the triangles would be congruent by side angle side similarity instead of angle angle. So a couple ways you could do it, more than one right answer. That's one of them.